Hello dear students, welcome to a new session. Today we'll be working on the relation between the inscribed and central angles subtended by the same arc. If you look at the circle that is appearing now on the screen, you will see that angle C is an inscribed angle and its arc is arc AB. The inscribed angle is an angle where the vertex of it lies on the circle and its sides contain two chords of that circle. So angle C is the inscribed angle and its arc is arc AB. Let's check the theorem. The theorem says the measure of the inscribed angle is half the measure of the central angle subtended by the same arc. Let's check one of the examples and solve it together. Here we have circle M. In each of the following figures, find the value of the symbol used in measuring. So in the first one, he's asking me to find X. In 2, asking me to find Y. In 3, is asking me to find Z. As you can see that angle C is an inscribed angle and its arc is arc AB. Angle M is a central angle and its arc is AB as well. So both the inscribed and the central angles are subtended from the same arc, which is arc AB. So in this case, the measure of angle C is half the measure of angle BMA. Then X is half the 110, then X equals 55. So X in this case equals 55. For question 2, C is an inscribed angle. M, or angle BMA, is a central angle and they both are subtended from the same arc. Then in this case, the 40 is half the Y plus 10. Then Y plus 10 equals 80. Then Y equals 70. Then in this case, as you see, Y is 70. For question number 3, you will see that the measure of angle AMB is double the measure of angle C. Then 3Z plus 20 equals 140, which is 2 times 70, as angle C is 70. So 3Z equals 120. So Z equals 40. Let me explain this again. C is 70 degrees, where BMA is 3Z plus 20. These are, C is an inscribed angle and M is the central angle, and they both have or are subtended from the same arc. Then measure of angle AMB is double the measure of angle C. So in this case, Z equals 40. Example 2. A is a point outside the circle M. AB is a tangent to the circle at point B. AM intersects the circle M at points C and D respectively, where the measure of angle A equals 40 degrees. Find with proof the measure of angle BDC. Let's check the proof together. Since AB is a tangent to circle at B, and BM, the dotted line, is a radius, then the measure of angle ABM is 90 degrees. In triangle ABM, the measure of angle A is 40 and the measure of angle ABM is 90, then the measure of angle BMC equals 180 minus the sum of 90 and 40, which is 50 degrees. Since the inscribed angle BDC and the central angle BMC are both subtended from the same arc BC, then the measure of angle BDC is half the measure of the central angle BMC, then the measure of angle BDC is half the 50, which is 25 degrees. Now, we're going to move on to one of the corollaries that we have, which is corollary number 1. The corollary says the measure of inscribed angle equals half the measure of the opposite arc. So, the measure of angle ACB is half the measure of arc AB. Corollary number 2, the inscribed angle drawn in a semicircle is always a right angle. If the arc opposite to the inscribed angle equals the semicircle, then the measure of angle C equals half the measure of arc AB. Since the measure of arc AB is 180 degrees, then the measure of angle C is 90 degrees. Let's see example 3. Study each of the following figures, then complete. How to find x in question number 1? X is an inscribed angle and its subtended arc is arc AC. So, as we just said, that angle ABC is half the measure of arc AC. So, in this case, you will see that x plus 1 equals half the 92. So, x plus 1 is equal to the 46. So, x equals 45. And now, how can we find the measure of arc AB? The measure of arc AB is 360 minus the 92 plus the 110. So, the measure of arc AB is 158. So, as we just said, x equals 45 and the measure of arc AB is 158. For question number 2, you will see that angle ACB is an inscribed angle. So, how can we find angle A? We're given that arc BC has a measure of 140 degrees. As you see that angle A is an inscribed angle and its arc is 140, which is arc BC. Then the measure of angle A equals half the measure of arc BC. So the measure of angle A equals half the 140, then the measure of angle A equals 70 degrees. How can we find the measure of arc AC? Arc AC is the subtended arc of the inscribed angle B. So can we find the measure of angle B? Definitely, yes. The measure of angle B equals 180 minus the sum of 60 and 70. So the measure of angle B is 50 degrees. Then arc AC is double the measure of angle B, so arc AC is 100 degrees because it's double the measure of its inscribed angle. So arc AC, its measure is 100 degrees. For question number 3, the first required angle is angle C. As you can see that angle C is an inscribed angle where its arc, subtended arc, is arc AB, which is a semicircle. So this angle C is an inscribed angle. So angle C is half the 180. So it's 90 degrees. So the measure of angle C is 90 degrees. And then the question is asking me to find the measure of angle B. If you check the measure of angle B, angle A is an inscribed angle. How can we find the measure of arc AC? The measure of arc AC equals 180 minus 128. So it's equal to 52 degrees. The measure of angle B is half the measure of its arc, then it's half the 52, which is 26 degrees. So as we said, the measure of angle B is 26 degrees. This is a very well-known problem. If two chords intersect at a point inside a circle, then the measure of the included angle equals half of the sum of the measure of the two opposite arcs. So the measure of angle AEC equals half the measure of arc AC plus the measure of arc BD. Another one, if two rays carrying two chords in a circle are intersecting outside it, then the measure of their intersecting angle equals half of the measure of the major arc subtracted from its half of the measure of the minor arc, in which both are included by the two sides of this. So here, the measure of angle E equals half the measure of arc AC minus the measure of arc BD. Let's go now and solve example 4. In example 4, in each of the following figures, find the value of the symbol used in measuring. So we want to find the values of x, y, and z in questions 1, 2, and 3 respectively. So for question 1, you will see that x is in the meeting point of the two chords inside the circle. So in this case, x equals half 60 plus 114. X is half arc AC plus arc BD. So x equals 87 degrees. For question 2, the y is half arc AD plus the measure of arc BC. So it's half 360 minus 150. So it is equal to 105 degrees. For question Z, you will see that the 115 equals half Z plus 130, so 230 is equal to Z plus 130, so Z equals 100 degrees. Let's move on to another example, which is example 5. The question wants us here to find x, y, and z. That here you can see that the angle or the two secants are meeting outside the circle. So for question 1, you will see that x equals half the major arc minus the minor arc. So x equals 35. For question 2, the 28 equals half arc EC minus arc BD. So 56 equals y minus 30, so y equals 86. Or in question 3, the 50 equals half arc CE minus arc BD. So the 100 equals 140 minus Z, then Z equals 40. So to summarize this again, question 1, x equals 35, question 2, y equals 86, and question 3, z equals 40. By finishing this question, we came to the end of our session. Thank you very much and good luck.